welcome to True Projects. In this video, we are going to explain about a project titled Prediction and Providing the Medication for Thyroid Disease using Machine Learning Technique. Thyroid disease is a widespread health issue impacting the numerous individuals globally, underscoring the need for timely and precise diagnosis to ensure the effective treatment. And this ambitious, we embark on a groundbreaking mission by harnessing the power of machine learning to transform the thyroid disease management. The scope of our project extends beyond the mere diagnosis. We also seek to provide the personalized medication plan tailored to individual patient profile by combining the data-driven insight and advanced machine learning technique. We aim to empower the healthcare professional and patients with target and efficient treatment strategy. Our vision is to significantly enhance the quality of life for individuals impacted by the thyroid disease. By leveraging the potential of the artificial intelligence and the comprehensive medical data, we aim to address the challenges in the thyroid disease management. Our predictive model will assist the healthcare professionals in making more informed decisions and enable the early intervention, leading to improved treatment outcomes and the overall patient well-being. The primary objective of our project is to revolutionize the thyroid disease prediction and the medication recommendation through the utilization of the machine learning algorithm. These algorithms include SVM, decision tree, neo-Bayes, and SPR with PCA features optimization. By harnessing the power of these diverse algorithms and optimizing SVM, we aim to develop a highly robust and accurate predictive model. The ultimate goal of our project is to achieve early and precise diagnosis of the thyroid disease, enabling the timely intervention and the personalized medication plan tailored to each patient's unique characteristic. By conducting the extensive experimentation and the validation, we aim to identify the most effective algorithmic approaches, ensuring that the insights provided the healthcare professionals are reliable and actionable. Our project represents a significant advancement in the field of medical diagnostic, offering the improved thyroid disease management and contributing to the better patient outcomes and the quality of life for the individuals which are affected by the thyroid disorder. These are the basic requirements that are needed to build this project. Python IDEL with version of 3.7, Anaconda with version of 3.7 or Jupyter. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know about the flow of the projects, these are the steps we need to discuss. The first one is importing the library. In this step, essential libraries and the modules related to the machine learning, like of data manipulation, visualization, are imported into the Python environment. These libraries include Pandas, NumPy for data handling, Seaborn and Matplotlib for data visualization, sklearn for machine learning algorithm, and Flash for creating the web interface. And the second one is importing the dataset. The dataset containing various features related to the thyroid disease patient is imported. The dataset include attributes such as whether the patient is on trioxin, query on trioxin, medication, thyroid surgery, query hypothyroid, query hyperthyroid, pregnant, sick, tumor, lithium, and of many more. The class attribute indicate the presence or absence of the thyroid disease. And the third one is data visualization. In this step, the dataset is explored and visualized to gain the insight into the distribution and relationship between the different attributes. Data visualization techniques such as box plot, scatter plot, and the correlation matrix are employed to understand the data distribution and identify any pattern or trends within it. And the fourth one is building the model. 4 machine learning models are constructed to predict the thyroid disease and recommend the medication plan. The first one is SPM, stands for Support Vector Mission. SPM is utilized as a powerful binary classification algorithm to predict the presence or absence of thyroid disease. It works by finding an orbital hyperplane that effectively separates the data points of the different classes, that is, patient with thyroid disease and those without. The SPM model aims to maximize the margin between the two classes, leading to the robust prediction for the new patient data. As the dataset contains the binary class label indicating the thyroid disease status, SPM is an appropriate choice for this prediction problem. And the second one is decision tree. The decision tree algorithm is employed as a tree-based classifier to predict the thyroid disease outcome based on the attribute in the dataset. It recursively splits the dataset based on the attribute value to create a tree-like structure. Each internal node of the tree represents a decision based on the specific attribute, and each leaf node corresponds to the predicted class label, as of presence or absence of thyroid disease. Decision trees are interpretable and initiative, making them valuable in understanding the contributing factors leading to the thyroid disease prediction. By analyzing the branches and the decision tree in the healthcare professionals can gain insight into the most significant attribute influencing the thyroid disease outcome and personalize the treatment plan accordingly. And the fourth one is Neobase. Neobase is employed as a probabilistic classifier to predict the thyroid disease presence or absence based on the categorical attribute in the dataset. It is suitable for handling the categorical data and works on the principle of the Bayes theorem. Bayes assumes that the attributes are conditionally independent given on the class label. Despite this assumption, it has to be proven to be effective in the various classification tasks, especially in the test classification and the situation with limited training data. In the project, Neobase helped to estimate the likelihood of the thyroid disease based on the presence or absence of the certain attributes. And the last one is SPM with the PCA feature optimization. SPM with PCA principal component analysis feature optimization is implemented to enhance the prediction efficiency and reduce the dimensionality of the dataset. PCA is a dimensionality reduction technique that performs the original feature space into the lower dimensional space by extracting the principal components. By reducing the number of features while retaining the most important information, the SPM model becomes more computationally efficient and less prone to overfitting. This optimization technique is beneficial in the scenarios where the dataset contains a large number of attributes, as it allows the SPM model to process the data more efficiently and produce the accurate prediction. By incorporating the PCA, the SPM model can handle a more significant volume of the data, making it a valuable addition to the thyroid disease prediction and the medication recommendation project. And the fifth step is training the model. The constructed machine learning model are trained using the dataset to learn the pattern and the relationship between the features and the thyroid disease outcome. The dataset is split into the training and the testing set to evaluate the model's performance. And the sixth step is user gives the input. A Flask web interface is set up to interact with the user, allowing them to input the thyroid related data. And the seventh step is the given input is pre-processed for prediction. The user's input data is pre-processed to ensure it matches the required format and is compatible with the trained machine learning model. And the eighth step is trained model is used for prediction. The pre-processed user input is fed into the trained machine learning model to predict the presence or absence of the thyroid disease and recommend appropriate medication plan based on the model's prediction. And the last one is final outcome is displayed. The prediction result for the thyroid disease presence or absence along with the recommended medication plan are displayed to the user through the Flask web interface. The displayed information aims to provide the valuable insight for the user reference and assist in making the informed decision regarding the thyroid disease management and treatment. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing of the various data files within it. The first one is dataset folder containing of the dataset that we used in this project and the test dataset that will be used to check the performance of the model. And the static folder containing of the various folders like of CSS, JavaScript, assets and vendor within it. And the template folder containing of the various HTML documents like of home, index, notebook, results, sign-in and sign-up pages within it. And the app is an py file which likely contains the information related to the front-end logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database and generating the dynamic content that to be rendered in the HTML template. And the model file contains the information of the algorithm and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is an file that is used to store the user information. And to execute the project, we need to build the Flask framework as of front end. And for the execution, first we need to copy this code folder path and then open the Anaconda prompt. Here first we need to change the location of the disk to F because our code folder is present in F disk. And then write a command the cd space and paste the code folder path. By this the directory will change to the code folder's path. And then click on enter button. Here we need to write another command this python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors and logical issues. After entering the enter button, the app.py file will run and the Flask framework will host the application locally at the default address like this. We need to copy this local link and then paste it on any of the web browser. I prefer to use the Chrome. And click on enter button. Here it redirected to the page as of like this, and consisting of the sign in and sign up buttons. Click on the sign up button. It will redirect it to the registration page containing of the necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. We need to enter the details like of the username and password as of admin, and password too as of admin. And then click on submit button. Here it will redirect it to the page like this. We need to fill these details to predict the thyroid disease. And here on thyroxine is of 0, and query on thyroxine is of 0, and on anti-thyroid medication is of 0, thyroid surgery is of 0, and the query hypothyroid is 0, and the query hyperthyroid is of 0, and pregnant is of 0, sick is of 0, tumor is of 0, and the lithium is of 0, and goiter is of 0, and the TSH measured is of 1, and the T3 measured is of 1, and the TT4 measured is of 1, and the age TT4 measured is of 1, and the age T4U measured is of 1, and the age is of 80, and the sex is of 1, and the TSH is of 1.4, and the T3 is of 0.8, and the TT4 is of 105, and the T4U is of 0.88, and FT1 is of 120. And then click on submit button. Here the result is indicated as thyroid disease risk is detected, and it is the recommendation of what the food we need to avoid as of like this, and the medication too. And by click on try again button, it will redirect back to the index page, and we need to fill the details as of like this. And here enter 0, query on thyroxine is of 0, and on anti-thyroid medication is of 0, and the thyroid surgery is of 0, and query hypothyroid is of 0, and query hyperthyroid is of 0, and pregnant is of 0, and sick is of 0, and tumor is of 0, and lithium is of 0, and goiter is of 1, and the TSH measured is of 1, and the T3 measured is of 1, and the TT4 measured is of 1, and the TT4 measured is of 1, T4U measured is of 1, and the age is of 15, and the sex is of 1, and the TSH is of 0, and the T3 is of 2.6, and TT4 is of 188, and the T4U is of 1.04, and the FTI is of 113. And then click on submit button. Here the page is redirected to the result and detected as no thyroid disease. In this way we can detect whether the person is suffering with the thyroid disease or not, and providing the medication too. And in conclusion, our project focused has made significant stride in improving the thyroid disease management through advanced machine learning algorithm by leveraging the SPM, precision tree, naive-bayes, and SPM with the PCA feature optimization. We have successfully developed a robust predictive model capable of early and accurate diagnosis. The integration of the PCA feature selection with the SPM further enhanced the model's efficiency and the performance. Through rigorous validation and experimentation, we have demonstrated the potential of the data-driven insight in recommending the personalized medication plan based on the individual patient profile, fostering the more targeted and the effective treatment strategy. This project's significance lies in the potential to revolutionize the medical diagnostics, empowering the healthcare professionals with valuable tools to make the informed decision, ultimately leading to the improved patient outcome and the higher quality of the life for those affected by the thyroid disease.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.